Look up, see that reddish spark in the night sky? That's Mars. Our planetary neighbor, a world of mystery and possibility. Humans are explorers. We crossed oceans, climbed mountains, and now, we look to the stars. Could Mars be more than just a destination? Could it be a new beginning for us? Terraforming. The idea is simple yet immense. To change Mars, to make it like Earth. To give it air we can breathe, water we can drink, a climate we can live in. This is not just building a colony, it is sculpting an entire world. Why Mars? It's not the closest nor the easiest, but it holds a special allure. It's somewhat like Earth, with seasons, polar ice caps, and evidence of past water. Terraforming Mars is a dream of a second chance, a beacon of hope for our species. Think about it, planetary engineering, altering the very fabric of another world. This isn't a project for a few years or even a few decades, it is a task for generations. It requires a vision that spans centuries, a commitment to a future we may not see. But the dream of a green Mars, a blue Mars, it pulls us forward. It inspires us to reach. Could Mars be our second Earth? Mars today has an atmosphere, but it's incredibly thin, about 1% of Earth's. You couldn't breathe it, it's mostly carbon dioxide. The pressure is so low your blood would boil. This thin air offers little protection, warmth, or hope for liquid water. Transforming this is the first great hurdle. Why do we need a thicker atmosphere? For many crucial reasons. First, we need to breathe. Oxygen is key, but even before that, we need pressure to keep water liquid on the surface and to shield life from harsh radiation. A thicker blanket of gas would also trap heat, warming the cold Martian surface. So, how do we build an atmosphere? One idea is to release gases already on Mars. The Martian polar caps hold vast amounts of frozen carbon dioxide. Warming the poles could release it. Factories could mine and process rocks, heating the regolith to free trapped gases. Orbital mirrors could focus sunlight, melting the ice, liberating the carbon dioxide. Another approach involves importing the necessary ingredients, comets and asteroids rich in volatiles like water ice, ammonia, and methane. Imagine guiding these cosmic snowballs towards Mars, letting them vaporize, adding to the air. This is a grand celestial delivery service. It's bold, complex, but it's a possibility. Slowly, molecule by molecule, building a new sky. The first step to a breathable Mars. Mars is cold. The average temperature hovers around -80 degrees Fahrenheit. Earth stays warm thanks to its atmosphere, a natural greenhouse effect. Mars, with its thin air, loses heat quickly and is farther from the sun. To make Mars habitable, we must raise its thermostat significantly. The key is that greenhouse effect. We need to trap more of the sun's energy. As we thicken the atmosphere with carbon dioxide, it will help. Carbon dioxide is a greenhouse gas. It holds heat. But carbon dioxide alone might not be enough. We might need even more powerful greenhouse gases like methane or artificial compounds. What about more direct heating? Consider giant mirrors in orbit around Mars, reflecting sunlight, focusing beams of light onto the surface. They could target the polar ice caps, accelerating the release of carbon dioxide and water vapor. Or they could warm specific regions, creating pockets of warmth, early habitable zones. Another trick changed Mars's color, its albedo. Mars is red because of iron oxide, rust. It reflects a good amount of sunlight. What if we made it darker? Dark surfaces absorb more sunlight, more heat. We could spread dark dust, perhaps from Phobos or Deimos, or cultivate dark hardy microorganisms. As the planet warms, these microbes could spread, slowly darkening the landscape, helping it absorb more warmth. A subtle, biological approach to planetary heating, turning up the heat on Mars, making it a warmer world. Life as we know it needs water. Liquid water. Mars has water. We see it in the polar ice caps, and there's likely much more underground, frozen solid. The challenge isn't finding water, it's making it accessible, making it flow. How do we get this water flowing? Warming the planet is the first step. As Mars heats up, the ice will melt, or more accurately, it will sublimate, turning directly from solid ice to water vapor. This vapor adds to the atmosphere, helping trap more heat. Eventually, with enough warmth and pressure, water could exist as a liquid on the surface. Imagine the first Martian puddles, then lakes. We need to find all the water Mars hides. Orbiters can map surface ice, rovers can drill. But what about deep underground? Could there be vast aquifers? Ancient hidden seas? Radar sounding can peer beneath the surface, searching for these lost reservoirs. If found, we could drill down, tap into them, bringing ancient water back to the light. Once we have liquid water, we need a water cycle, just like on Earth. Evaporation, clouds, rain, rivers, oceans. This is a complex dance. It takes time, requiring a stable, warmer climate and a thick enough atmosphere to support it. Early Martian rain might be acidic or briny. It will take many centuries for the water to purify, for ecosystems to form. But the dream of Martian oceans is powerful. A blue Mars teeming with possibilities. There's an invisible danger on Mars: radiation. Earth is protected by a global magnetic field, a natural shield that deflects harmful solar wind and dangerous cosmic rays. Mars lost its global magnetic field billions of years ago. Its core cooled, the dynamo died. Now its surface is bombarded. This radiation is a threat to any future life and can strip away the atmosphere we build. Cosmic rays are high-energy particles that can damage DNA and increase cancer risk. Solar flares unleash bursts of protons. Without a strong magnetic field and with a thin atmosphere, the Martian surface gets a heavy dose. Early colonists would need significant shielding, underground habitats, thick walls. But for a true terraformed Mars, we need a planetary solution. Could we give Mars an artificial magnetic field? One concept is a giant magnetic dipole, a powerful electromagnet placed in orbit or at a Lagrange point between Mars and the Sun. It would create a mini magnetosphere, deflecting the solar wind and protecting the planet. This requires immense power and advanced technology, but it's theoretically possible. Another idea involves a network of surface stations creating local fields. A thick atmosphere itself provides some protection. Air molecules absorb and scatter radiation. Even without a magnetic field, a dense Martian atmosphere, say, half as thick as Earth's, would significantly reduce surface radiation. This might be enough for hardy life forms and for humans with some added protection. So, building up the air is a double win. It helps with warmth, water, and radiation. Do we have the technology for such a grand feat? Terraforming Mars? Today in 2025, the honest answer is, not quite, not yet. We have some of the building blocks. We can send robots to Mars, study its climate, and understand atmospheric physics. Rocketry is advancing. We can imagine the steps, the processes. But the scale is the challenge. The sheer magnitude of planetary engineering is beyond our current capabilities. Many terraforming technologies are still theoretical or exist only in labs, so what can we do now? We can start with smaller steps, more manageable goals. Para-terraforming, creating enclosed, habitable zones, like giant greenhouses on the Martian surface. Learning to walk before we try to run a planet. The first steps towards a new world. Terraforming Mars will not be cheap or quick. The resources required are almost unimaginable. Think of the energy needed to warm a planet, build an atmosphere, power giant machines and orbital structures. It would dwarf humanity's current total energy consumption. We'd likely need new energy sources, practical fusion power perhaps, or vast solar arrays. The cost in monetary terms would be astronomical. Then there's the sheer amount of materials. If we import volatiles, that's millions of comets or asteroids. Building orbital mirrors requires mining and manufacturing in space. This is not something one nation can do alone. It would demand a global effort, unprecedented cooperation. All of humanity working together for a shared long-term goal. The economic, political, and social challenges are immense, as daunting as the technological ones. Who pays? Who manages this colossal project? And the timeline? Forget about quick results. Terraforming is not a project for a human lifetime or even several lifetimes. We are talking centuries, millennia. Changing a planet's climate, building a breathable atmosphere, creating oceans, these are slow geological processes. Even with advanced technology, it will take time. Patience on a species-wide scale, a commitment to future generations. This is a project for our distant descendants. They would inherit a Mars in transition, a world slowly awakening. The cost is measured not just in money but in time. Beyond the how, there's a bigger question: should we? Do we have the right to remake another world, to impose our vision of life onto Mars? Mars is a pristine, ancient place. It has its own history, its own integrity. Is it an act of cosmic creation or cosmic vandalism? These are questions we must grapple with. Terraforming Mars is a dream for the distant future. It is a powerful dream, a compelling vision. It pushes the boundaries of science and technology. It inspires us to think big, to aim high. The very idea of a second Earth captures our imagination. It speaks to our deepest aspirations, our yearning for new frontiers. The journey itself will teach us so much. The effort to understand Mars, its climate, its geology, is invaluable. It helps us understand our own planet better. The quest for Mars is also a quest for self-knowledge. Perhaps the path to a green Mars is gradual. We might start with small protected habitats, each step a small victory. Mars beckons. It calls to our adventurous spirit. The dream of terraforming is a testament to human ambition. The journey to Mars and beyond is a journey into our own potential. The future is unwritten. Let us write it boldly,